called Math 8-7. That's what the book is. I think your schedules say Math 7 or something like that.
7-8.
Yeah, 7-8 or whatever. But this is Math 8-7. This is lesson 1. And we're going to talk about a few things. We're going to talk about the different types of numbers and operations. So I'm going to say numbers and operations. Okay? So the most basic set of numbers, group of numbers, are called counting numbers. Can someone give me a definition of counting numbers? Like, what's a good, if you had to explain counting numbers to your little brother or sister, what would you say?
1, 2, 3, 4, 5, 6, 7, 8.
Yeah, you could just tell me the numbers, but how do you define that to your little brother or sister? You gotta.
The 1 through 10, the numbers you count with.
The numbers you count with. That's a great way to define it. These are the numbers you count with. So, for example, I wouldn't say, okay, let's see how many people are in this class. 0, 1, 2. Is that how you count? No, and that's not very nice. I mean, he's more than a 0, right?
It's a 10.
So counting. Ooh, you're a 10. Congratulations. Okay, so 1, 2, 3, and then what does this mean?
It keeps continuing.
Yeah, so it's, do you guys know what that's called? It starts with an E. I'd be so impressed if you knew.
Eternity.
It's such a fancy word.
Etc.
No, but that's a cool word too. It means the same thing. Starts with an E. Here's a hint.
What? Wait, what?
It's got the word lip in it. It's called an ellipses. Say that word at parties. It's going to be real popular. So ellipses. So that just means continue on in the same pattern. Okay? So we're just adding 1 to each number. All right? Counting numbers. There's another name for counting numbers. No, that's actually the next set of numbers. But there's another name for the set of counting numbers. They call them counting numbers or natural numbers. Natural numbers. What? Natural numbers, that's right. AKA natural number. Because what numbers come naturally? If I say, give me a bunch of numbers, you'd say 1, 2, 3, 4, 5. Right? You wouldn't say 0, 1, 2, 3, 4, 5. No, you'd say 0, 1, 2, 3, 4, 5. Okay? So whole numbers are a little different, literally a little different, because there's only one number that's in the set of whole numbers that's not in natural numbers. Do you know what it is? Yes. Whole numbers are just like counting numbers, except they have a hole in it. See what I did there? So that's a good way to remember the difference between whole numbers and counting numbers. Whole numbers start with 0. Counting numbers start with 1. Okay? Questions so far? So far, so good? All right. So, and then we're going to talk about different numbers after this. Like integers are all the whole numbers and then they're opposites. So you put a negative sign in front of them. Okay, so instead of 0, 1, 2, and 3, you've got -1, -2, -3, all the way in that direction. Okay, so how big is the set of whole numbers? How big is it? Infinity. I thought you were going to say real big? Really big? Yeah, it's really big. So in math, if a number is really big, we just call it infinity. So here's like the 3 most popular answers in math. 1, infinity. 2, 0. And 3 is 1. So those are the 3 most popular answers. If you don't know and you're called on and you were talking and you weren't paying attention, I say, hey, can you infinity? Then you might be right. So because chances are you might be right. So but it doesn't happen a lot, but it's there. Okay, so whole numbers. So they don't include any numbers less than 0 or in between numbers. So like 1.5 is not part of any of these sets. They're the whole numbers. So like a whole pizza, that's all you get. You don't get part of a pizza like fractions. It's just whole pizzas. Now I'm hungry for pizza. But, so it's not any number in between. So there's still a bunch of numbers. How many numbers are in between 1 and 2? If you don't know, what do you say?
Infinity.
Infinity, that's right. Isn't that crazy? Because just infinity can be infinitely big, and it can also be infinitely small. So, do this. All right, this is a little fun experiment. Okay, try to put your finger as close as you can together. All right, now, your hands are shaking a little bit or whatever. Do you think you could cut that distance in half if you had like a microscope and like you could just get it in half? Do you think you could do that? Okay, it's physically impossible, but theoretically it's possible, right? Because what's half of an inch? Half inch. What's half of an inch? Quarter inch. What's half of a quarter of an inch?
1/8 inch.
Okay, see how you can just keep going to infinity, infinitely small. Isn't that crazy? Now technically, I just confirmed this next door. This is why it's great to be by my brother. But technically, you're not really touching your fingers together.
Because they're atoms.
Yes, that's right. So, like, I'm not really touching my fingers together. Isn't that crazy? Like, I could just hit Dylan in the face, and I wouldn't go to jail because, hey, I didn't touch him.
That's
Okay.
gonna be like my only excuse to my mom now. I'm gonna have to
That's
tell her
right.
sorry.
I didn't touch. Did you touch this?
Nope.
No, never. So, and you wouldn't be lying. You'd actually be smarter than most people around you. Okay? So, anyway, there are an infinite number of numbers in between 1 and 2. That's just crazy to me. Okay? I can kind of get my head around infinitely big, but infinitely small just boggles my mind. Okay? All right. It's not easily boggled either. So there are 4. I'm going to try a different marker. These markers are lasted long. 4, this is good. Fundamental operations of math. What are they? Do you know, Addie?
Multiplication, subtraction,
Addition.
and
Divided.
Good job.
the plus sign.
The plus sign. That thing. Plussing? Is that right? Plussing? No. 4 fundamental operations. So fundamental, do you guys know what fundamental means? The word fundamental? What that comes from the word foundational. It's the same word. Fundamental is foundational. That's the same word. Okay, it means the same thing. So like a foundation in the house is what the house is built on. So you'll see that in a lot in math, that there are fundamental things that are built upon. So if you don't understand those fundamental things, then your house isn't going to be very strong. Did we already sing that song? Wise man built his house upon the rock. You know that song? Anyway, and then the built the house on the sand, and the walls came tumbling down.
Oh.
Well, that's kind of horrific. But, yeah, 4 fundamental operations. So we're going to just call it add, subtract, or addition, subtraction, multiplication, division. Add, subtract, or plussing. That's what the cool kids are saying. So, multiply, divide. And you guys know the symbols of that? Add, it's the plus sign. Addie knows that. Subtract, it's the minus sign. And then there's a couple symbols for multiplication. Do you guys know them? So I saw this in the air. So the X, what else besides the X?
The straight line?
The straight line?
What?
So that you're thinking of division.
No, it's not parenthesis, it's the like.
Parentheses.
Yeah, like
Yeah, the.
or
it's
absolute
not-
value, like parentheses if they're right
skinny
next to each
Cs.
other. Skinny C's, those are parentheses. Yeah.
but
Yeah, those are parentheses. There's parentheses, there's brackets, there's braces, but yeah. Okay, anything else?
A dot. I think
Yeah, so the dot's there. And then if two numbers are next to each other, like 5 next to a 3, well, that means 53, right? But if one of them is in parentheses, like Kiara said, then it means multiplication. So 5 parentheses 3 would mean multiplication. Okay? Then division, here's a cool thing. This is actually the original division problem. So like if I wanted to say 12 divided by 3, I would write it like this. And it wasn't until recently where mathematicians were like, you know what? I don't want to write it on 2 lines. I just want to write it on 1 line. So what they did is they created this symbol where they took that line and they put it right here, and then instead of writing it on top of each other, they just put 2 dots. So 12 divided by 3. So see where that symbol comes from? Isn't that cool? Did you guys know that?
Mm-hmm.
I learned that from Steve Demme. Raise your hand if you know who Steve Demme is. Not Steve Dummy, Steve
I
Demme.
don't even know.
Math UC, baby. Anyone do Math UC? Nobody? Oh my goodness. Math UC is awesome. So he did all these tutorial videos and he like talked about the origin of this division sign. Mind blowing. What's another symbol for division? Yeah, the box thing? Is that what you're gonna say?
Yeah.
Okay, now, I also learned this from Mr. Demme. So 12 divided by 3, right? Okay, well, what happens if this was like a rectangle? What are the dimensions of this rectangle? If the area of the rectangle is 12, what would this side be?
Oh, that makes total sense.
Isn't that cool? So remember that area is length times width, you multiply them together. So that's where this symbol came from. This is like half of a rectangle. So this is the area of the rectangle, so these are the 2 sides. Isn't that cool? Your mind is blown, isn't it?
Yeah.
There's paper towels up here if you need to clean up brain matter on your desks. But yeah, your mind's going to be blown a lot in this class because it's pretty mind-blowing. All right? All right. I don't know how you can go on from there, but we will. So that's division. All right. And here's the deal. All of you guys know how to add, subtract, multiply, and divide. The trick, when it comes to word problems especially, is knowing when to add, subtract, multiply, and divide. Okay? So we're going to learn some tricks, some keywords that help us. Ooh, that sounds like an addition problem. Ooh, that sounds like a multiplication problem. So that's like the first question you normally ask when you do a word problem. Okay, what do I do here? Do I add, subtract, multiply, or divide? Well, we'll get there, but we're not going to do that today. So let's talk about addition. And there are 3 parts of an addition problem. Something plus something equals something. There are words for these somethings. Grady, do you know?
Addend, sum.
Addend, and then the answer to an addition problem is called a sum. Good. All right. Okay, so this is where I lose people. Does anyone know the 3 parts of a subtraction problem? Do you know? Oh my gosh. You're like the first one in history to know. Do you know too?
I know one of them.
Okay, what's one of them?
Subtrahend.
Subtrahend. Okay, which one is the subtrahend?
The middle one.
Yes, you're right. Did you know all of them?
Minimum and subtrahend difference.
Nice. Okay, that is crazy. Because here's what I normally do, and I'm glad I didn't because I would have been out $5. I would I'll give someone $5 if they know these 3 terms. So thanks for saving me the $5. But you deserve $5, don't you? I don't think I'm legally able to give you $5. But we'll figure it out. All right, so that's the part of a subtraction. Why does subtraction have 2 different names, but addition has just 1?
Because you're adding 2 of the exact same things, but.
Well, not the exact same. It could be 3 plus 5 equals 8, right? But anyone know? Do you have an idea?
For addition, it doesn't matter what order it is.
Yes.
Subtraction, it does.
Right, so 3 is the first add-in. It doesn't matter if it was the first add-in or the second add-in. 3 plus 5 is going to be the same thing as 5 plus 3, right? But minuend is for what we're doing now, we're not getting into negative numbers yet. Minuend is usually that bigger number. The subtrahend is the smaller number, or what you're subtracting from the bigger number. And the difference is what you have left over. So there has to be an order. 5 plus 3 does not equal 3 minus 5, okay? So when you are starting to do your problem sets and you have not been in school for 6 months, because that's about how long it's been, right? About 6 months. A rookie mistake is doing something like this. Okay, subtract. All right, 3. Okay, that's 2, 3, 1. Got it. Okay? So, subtraction is not reversible. You can't just subtract whatever's easier. So, don't do that. Okay? I know none of you would do that, right? None of you would do that. You're like, wait, that's wrong? Okay, what about multiplication? Somebody else. Can somebody else tell me the 2 F words? Not those. Don't say that. What are the 2 F words? Think before you talk. Anyone? It does start with an F.
I know at the end it's the product.
Product is the answer. That's right. Factor, that's right. Good job. So factor times factor equals product. So do you guys remember factor trees? So basically you started with the product and you broke it up into factors. Remember the 15 and then you do the little factor tree, 3 and 5. We're going to do some of those. It's going to be awesome. And then division, here's the other tough one to remember. And these are different too because remember, you can't switch the order of division. You can in multiplication. 3 times 5 is 15. 5 times 3 is 15. But 12 divided by 3 is not 3 divided by 12. Do you remember?
Yes.
Okay.
Dividend.
All right. Dividend, yep.
And then divisor.
Yep.
And then forgot the last one.
Starts with a Q.
Cute.
It's cute. It's a cute answer? Okay, do you remember?
Is it a quotient?
It is a quotient. That's right. All right, there's another name for a dividend and a divisor. It's called a numerator and a denominator. Because every fraction is a division problem, right? So you got your divisor, or dividend, divided by your divisor, equals your quotient. Well, what does that look like? That's just a fraction. So every fraction is just a division problem, okay? It's weird to think about fractions that way, and we won't, but fractions are usually this much out of this many total parts, but we'll talk about that a little bit later. But these are the 4 basic fundamental operations of math, okay? So, that's lesson 1. That's not bad for lesson 1, right? Because this is stuff that you learned years ago probably, but this is a good refresher. And some of you are a little rusty from not doing math for 6 months. Actually, you do math.
Literally every single day.
Yeah, my mom made me
we
do math in the
math.
summer.
Yeah, I
That's
know.
good. That's
It
good.
was like the total one. No, I don't need to.
Okay, well, you guys are doing math every day. Anyone, did we talk about this? If you set your alarm, I do math every morning because when my alarm goes off, I like add 9 every time. Okay, when will I wake up if I hit snooze? Because I don't know why they add 9 minutes for snooze.
I know it should either be 5 or like 6.
But you know why they do it? Because they want you to do the math so it's easier to wake up. maybe. All right, there's one more thing in lesson 1. There's just talking about you can write money in 2 different ways. Right, you can write 50 cents. How do you write 50 cents? There's two ways to write 50 cents. Okay, what's one way, Kiara?
0, the decimal point, 50, and then the dollar sign.
Okay, yeah, so we'll put the dollar sign on the left. That's one way. What's the other way? Do you know, Addie?
50 and then a little cents.
Yep, and this one goes on the right. Okay, here's what one time I went to a garage sale and they were selling CDs. Do you guys know what CDs are?
Yeah.
All right, so because CDs are like a dying thing, they're kind of like VHS tapes. You guys probably don't know what VHS tapes are. Okay, so CDs, and say all CDs are 50 cents. That's what they were selling them for, and they wrote it like this.
Oh.
So you know what I did? I grabbed, what did I grab? I grabbed like 10 CDs and paid the person 5 cents. I'm like, this is what they're priced at.
This isn't it like, I think half?
Yeah, because that's a half of a cent. 0.5 cents, right? So I can buy 2 for a penny. So I'm like, you gotta label your stuff correctly. I'm not gonna give you 5 cents, but I'm just trying to teach you. I never did that. I'm making up this story as I go.
Okay.
But I could have been that guy. I mean, legally, I can have 10 CDs for a nickel. All right, so I'm gonna call the police if you don't give me my 10 CDs for a nickel. Okay, but that's what they did, and I'm like, bummer. They must have gone to A West or something. Just kidding. I'm just kidding. Okay. All right, so that's lesson 1. Let's go to lesson 2. So far, so good. You guys have any questions? Remember, if you have a question, even if you think it's, let me just clarify something. You know that saying, no question is a dumb question? Not true. Okay? Every question is a dumb question.
That's where my brother got it from.
Yeah. Otherwise, you wouldn't be asking the question, right? Like, what's that again? Well, technically, you're dumb to that answer, right? And so let's just all be dumb together and ask questions. When I say, how are you? I'm dumb because I don't know how you are. Okay? I'm dumb to the fact of how you're doing. So every question is a dumb question. So can we just agree on that and be okay with every question? So is that a dumb question? This is kind of a dumb question. Yep, it is. And you haven't even asked it yet. Okay? So yes. If you have a question, most likely another person is also dumb for not knowing the answer to that. So let's be dumb together.